I welcome all of you for this video session, and today I would like to share about the introduction of heat transfer with you. And this heat transfer subject is meant for 5th semester mechanical engineering students, and those students learn the thermodynamics in the 3rd semester. And this both the subject deals with the heat energy heat energy and first of all I would like to tell about the thermodynamics. So what is thermo and what is dynamics? So thermo is nothing but the heat, and the dynamics is nothing but the force analysis. Dynamics is nothing but the force analysis. Okay, so if you want to analyze any system in terms of thermal analysis, you should consider few parameters. Okay, so what are the parameters? Now I am going to tell. First one is heat energy, second one is work, third one is mass, fourth one is rate of heat transfer, and fifth one is modes of heat transfer. Total 5 parameters we are considering in order to analyze a system. Okay, so this thermodynamics, the subject deals with the heat analysis only. Okay, so the difference between heat transfer and this thermodynamics, first you should know. Okay, I will provide one example for this. Okay, consider a cup of hot water which holds the temperature of 100 degrees centigrade. Okay, consider a cup of glass water which holds the temperature of 100 degrees centigrade on this table. Okay, so after few hours or few minutes, what happens to that water? It will reach us to uh, the temperature of the water reaches to the temperature of the room temperature or the ambient condition. It will reach the ambient condition. Okay, so slowly it loses its heat, okay, to the surrounding. Okay, and when it reaches to the room temperature, the temperature is balanced to each other. Okay, so this thermodynamics tells the final state of the system. Okay, take for an example, just before I told an example now, a cup of water is on the table, hot water is on the table, and if you analyze using the thermodynamics subject, you will get an answer for the room temperature, for the final state only, that is room temperature. Say for an example 30 degrees centigrade. Okay, so if you convert the same thing into application, take for an example, if you want to manufacture a flask. Okay, so in the to carry hot water, coffee or tea. Okay, so if you go to a shop for buying this hot flask, thermo flask, the shopkeeper will tell about the different parameters of the flask or different features of the flask. So first flask, when he take the first flask, and he tells this flask holds the it will hold the temperature up to 4 hours, and he will bring another flask and show it to you, and he will tell this flask will holds the temperature, the hot water, of about 6 hours or more than 6 hours. He will tell how he is telling this range. this flask holding 4 hours and this flask holding 6 hours, or another flask holding more than 6 hours. How he can tell? So this thermodynamics only takes the two condition, heat energy, two parameters, heat energy and work. Okay, it will take only heat energy and work. Okay, and it omits the mass transfer, rate of heat transfer and modes of heat transfer. Okay, so these three major parameters are needed if you want to convert the thermodynamics knowledge into the in any useful application, into any useful applications. Okay, so that's why you are learning this heat transfer subject. Okay, so now we are now look at this slide. I have presented three different modes of heat transfer. Normally, just before I told three things we left out from the thermodynamics subject. First one is mass transfer, second one is rate of heat transfer, and final one is modes. Okay, so if you want to learn the basics of heat transfer, you should know three different modes. What are the three modes of heat transfer? Okay, so first one is conduction heat transfer, third one or second one is convection heat transfer, and final one is radiation heat transfer, which I mentioned on the screen. Okay, conduction heat transfer, convection heat transfer, and radiation heat transfer. Okay, so let us explain the conduction heat transfer at first. So take for an example, the heat transfer takes place between two solid objects. Okay, two solid objects. We can call it as a conduction heat transfer. Okay, so next we are going to learn the convection heat transfer. What is convection heat transfer? The heat transfer takes place between liquid to gas or liquid to solid to liquid. Both we can call it as a convection heat transfer. And final one is radiation. Heat transfer takes place without any medium. Okay, uh, the heat transfer only takes place through by means of electromagnetic waves. Okay, take for an example sun and earth. Take an example sun and earth. We are feeling the heat of the sun in our on our earth. Okay, we can sense it in our body by means of radiation. There is no contact between yeah, us and the sun. Okay, there is no medium. Okay, there is no any connecting medium between the sun and the earth. Okay, the heat transfer takes place by means of only electromagnetic waves, that we can call it as a radiation. Okay, so next slide, which deals with an example of the convection and radiation heat transfer. Okay, so just go through the slide on the screen. It depicts the pan, a steel pan. Inside the pan, the water is filled. Okay, and just below to the pan there you can see a banner. Okay, which flames, which emits flames. Okay, so you know about the boiling point of the water. You might have aware about the boiling point of water, which is 100 °C. Okay, so first of all I would like to tell the conduction heat transfer, where this conduction heat transfer takes place. Just go through the diagram and just think. The conduction heat transfer takes place between the flame and the steel. Then it transmits its energy, heat energy, to the liquid medium. Okay, liquid medium, that is convection. So first of all, conduction. What happens to the steel medium? So you might have aware about the material science. Okay, so the steel consists of atoms, molecules, etc. Okay, how this heat transfer takes place? Because of the intervention of the heat energy, what happens? The molecules present inside the steel got vigorously vibrates. Okay, vigorously vibrates. Okay, and become denser. Okay, and hits to the other molecules, and the by such a manner the heat transfer takes place. Okay, to the solid medium. And when it is reaches the liquid medium, what happens? It absorbs the heat energy from the steel, and at the 50 to 60 degree centigrade pool boiling, or the bubbles will form. Okay, and inside the bubble gas will be there, and the gas also carries some sort of heat energy. Okay, so this transfer, heat transfer, we can call it as a convection heat transfer. Okay, liquid to gas, or water vapor, liquid to water vapor, we can call it as a convection heat transfer. And uh, when you go nearer to the pan, or if you move your hand just closer to the pan, don't touch that pan, just move closer to the pan, you will sense some sort of heat. Okay, it emits some sort of heat. Okay, so normally in the world, uh, all the materials which is above 0 degree centigrade emits some sort of radiation. Okay, some sort of radiation, some sort of heat. Okay, to the surrounding, it's the nature. Okay, so that if you move towards the pan, you can sense the heat. Okay, so by means of electromagnetic radiation, this will electromagnetic waves, this radiation heat transfer takes place. Okay, so that's all about the modes of heat transfer. Next, we can move to another one slide, which I am going to explain the application, one application of heat transfer. Okay, so normally the heat transfer, if you take heat transfer application, we are exchanging, normally the application deals with the exchanging of heat energy to one region to another region. Okay, so here, this picture, see the picture on the screen, which depicts the layout of the thermal power plant. Okay, so I am not going to explain the whole thing. Okay, just take the boiler itself. Okay, here you can see the boiler. So what is presented in the boiler, or what is inside the boiler? Water. Okay, so water is filled in the boiler. Okay, so this is thermal power plant, so we are using coal. Okay, in order to produce the energy. For nuclear power plant, we are using uranium in order to what? Produce the heat energy. Okay, so when you supply the heat energy on the boiler, what happens? The water absorbs the heat energy. Okay, the boiler, what happens to the boiler? The conduction heat transfer takes place on the boiler, and it transmits heat transfer to the water by means of convection heat transfer. Then again, if you raise the temperature, what happens? The all the water present in the inside the boiler will converted into what? Vapor state. Okay, pressurized vapor state. So that is convection heat transfer, and this pressurized steam is introduced to the turbine in order to rotate the turbine to produce the electricity. Okay, so most of the all heat power plants are functioning in this manner only. Okay, So this is the one of the applications of heat transfer, and we can move on to next slide. And so many applications. Okay, so in this slide I mentioned few applications. Okay, few applications of heat transfer. In our daily day-to-day life, we are in the kitchen also. We are using lot of devices. Okay, lot of devices. Take for an example, electric stove, all electromagnetic stoves. Okay, then grills, etc. We are using. Then in our room we are using air conditioning system. Okay, then electronic devices we are using in computers. Also, we are using what, a fan in order to cool the what, the processor. Okay, that is chip. One processor chip is there. In order to cool the processor, we are using some fan to by means of convection heat transfer only. Okay, in automobiles we are using many heat transfer systems. Okay, and below to this I have mentioned the industries and technologies. And just before I mentioned now about the thermal here, but thermal power plant now, there also we are using the heat transfer what concepts. Okay, then in manufacturing, subsequently you can see in chemical engineering, environmental engineering, medical engineering, medical applications, etc. Okay, so that's all about the introduction of heat transfer. Thank you. Thank you.